Our next speaker is Martin Golasowski and Tobias Jancha from IT for Innovations, Technical University of Ostrava, and his talk is entitled Update on iRODS Distributed Data Management in the LEXIS Platform.
Okay, thank you very much. So I'm Martin. I'm a senior researcher with the IT for Innovations, which is the National HPC Center of the Czech Republic, and I will give you the update on how we use the iRODS in LEXIS, what we did since the last year, and what is our plan. So, and just to recap, what LEXIS is actually a platform, online platform that allows us to provide to our users easy access to supercomputing, meaning that if you want to execute anything on the connected supercomputers, you don't have to use any terminals, you don't have to do any SSH. You can upload your data using our platform to the supercomputer. You can run things on a supercomputer. You can define workflows, access the logs of your applications, launch the jobs, and so on. Everything with the browser as well as the API. With the API, we have also Python SDK, ARP SDK. Everything is open source, and we have the links there, lexis.tech, and we have a GitLab repository with all the codes there. So, but I think that this picture maybe illustrates best what you can do with the platform. This is the most simple thing you can do is execute something we call a simple HPC workflow. Yeah, because we saw that 99% of the things or the workflows which are being run by the HPC users look like this. So you go to the cluster, you prepare your job directory, then you somehow stage, upload, move, transfer, download your input data to the cluster. Then you prepare a job script and submit the job script as a job to the scheduler. Then you get an ID, you wait until the job changes the status, either success or unsuccessful, depends. And then you download or access the result in any way. Yeah. So this is the most basic thing you can do in our platform, and we have a template for that. Essentially, we have the workflow templated, and if you use it in our platform, we have to define the input data. Yes, select the data set which you can upload before. Then you can define the source of the job, like what is the job being executed. It can be either a pre-prepared, we call it command template. It's like fine-tuned job script for certain applications, like GROMACS or some CFD stuff, which has to be fine-tuned for a particular cluster. You can just define parameters of this job script. Then you can upload your completely custom job script. You can upload an obtainer container and have it executed, and then you run the workflow. Yeah, and all those steps are being handled automatically by the platform. Yeah, and then the result actually appears as a data set in a platform, and you can download it, you can view it, certain limit, of course, yeah, and so on. But I think what is very important to say is that this is a very flexible thing. You can also use the declarative approach and visual workflow builder, which I will show also later in our solution, and you can define a completely arbitrary patterns using the workflow definition language, and you can even use multiple systems in one workflow. We will also have a smart scheduling capabilities and so on. Yeah, so all of this is very flexible, and we offer these functions through web browser, or through web interface, or through an API with some SDKs on top of that. But let's focus on where the iRODS is actually here in this picture, because we use iRODS to store data in our platform. The platform looks like this. The architecture still didn't change. It's still the same. We have components in the core. The data component is actually here. It has an open search metadata index, but we use it in a slightly different way. We don't use it through the plugin. We have a synchronous way how to talk to the index and to the iRODS. So first, if we create a data set, the data set is first created as a record in the open search, and then it is in the same call, synchronous call is created also in iRODS, which may reside on one of the connected locations, which are here down below. And those boxes below actually represent the different HPC sites, or in general some nodes which can connect some resources to the LEXIS platform. But we strictly follow the user space. We strictly follow the allocation model, which is common in HPC in terms of node hours and some storage allowance. We have just deploy a bunch of VMs in each of the sites, and this allows us to have a site connected as a node in a platform. Yeah. So we actually operate two instances of this platform. One instance is part of the EuroHPC Federation platform. It's called EFP Workflows. So if you have each EuroHPC allocation, you will most likely encounter this one on the myeurohpc.eu. And we also have our national LEXIS platform instance at lexis.tech. And this is what we use for national activities to connect national infrastructures together. And also we use that for our EOS CZ integration with other repositories and so on. But more on that later. Yeah. So, but in general, the architecture still is the same. Some things on the core. The core exposes the APIs and the web portal and so on, and a bunch of integration components on the below. So focusing on the iRODS role in the LEXIS platform, we use the iRODS as a way to ensure data locality and on a particular HPC center or data center, because each HPC provider usually has one or more data centers. They have HPC clusters and some storage is usually next to them. Yeah, and what we do, we have some components in the core here, and if user interacts with the components, then he sets the metadata, he creates the data sets, and then there is some component called DDI, which synchronizes the structure with the iRODS zone selected by the user. The iRODS zone then uses the local storage available provided by the HPC data center. And then the user can actually download and upload the data. What is important to say is that we have completely eliminated any centralized proxies or endpoints through which the data flows. Everything is done directly between the user and, for example, web browser client and a target iRODS zone. Yeah, the data doesn't flow through any centralized cloud or anything. Yeah. Then, in order to do that, we leverage the OpenID functional integration with the HTTP API. And as I said, we strictly follow the HPC allocation model, meaning that if someone wants to consume some resources through LEXIS, they have to have an allocation of node hours, and there is certain storage allowance with that. And this is something we synchronize here. Yeah, we enforce the structuring of the zone collections by some synchronization script we have, and the structure corresponds to some virtual LEXIS project we have, and the individual allocations which are associated with a particular LEXIS project. So iRODS here efficiently provides us a very nice way how to represent completely different storage backends, maybe some locally mounted POSIX, all flash, HDDs, S3, whatever. Yeah, this is what iRODS brings us. And then we have mechanisms to actually stage the data, meaning that we take the input data set from the local iRODS zones, and then we push it to the HPC cluster parallel file system through some user space tool, either in a job script or through an SSH by default, because HPC clusters expose most commonly SSH, yeah, in the front. So focusing on the detail, this is what we have technically inside. We have our user here, which talks to our platform through web frontend or Python CLI. Then we have metadata API, which takes care of the metadata index and talks also to the iRODS using iRODS HTTP API to create a structure, the collections, and so on. Then we have a staging HTTP API, which also runs in the core on the left, and it talks to a staging worker, which then actually moves the data between the local iRODS zone and the HPC cluster storage. And we are also we have also some integration in place, which allows us to ingest the data from some remote resources like DSpace or some remote S3 storages and so on. And then we also included a new component called HTTP to transfer API, which allows us to provide user direct pathway to actually upload or download data to the target resource provider without any middle proxy in between. Yeah, and this is something we would like to also focus in the future to streamline the APIs we use to actually talk to the iRODS, yeah, because here you can actually see two, and we have some ideas in mind how to probably merge them together. So what we did since the last, let's say, year and a half, we moved to iRODS 5.2 more specifically, and working on iRODS 5.1. And we have HTTP API 060 deployed on the locations now, and working on 070. Moved completely to jQuery 2. And thanks to all the improvements, we have the great usability now, thanks to the HTTP API. This is just an illustration. The screenshot here is not the jQuery API, but this is one of the great strengths of the iRODS, which we use, is that it allows us to register our own SQL queries in a server. And this actually helps us query the data set sizes very quickly on the target zone. Yeah. And this is how we can actually display the column that says dataset size very quickly because this is something we cannot sync with the OpenSearch, because it would be inconsistent, it would be hard to sync, but we use this. This is one of the very, very good features we leverage here. And then, of course, some code refactoring. This is mainly Tobias's work and so on, and our colleagues moved to some more strongly typed code, better CI/CD and so on, and the HTTP2 protocol, which we currently provide also as a means to access the HTTP parallel file system directly. It leverages parallel SFTP library, which we developed in Python. And the idea is also we may consider to use this API also to talk to iRODS directly, either through HTTP API or through the Python iRODS client. Don't know yet. Yeah. But something about lessons learned throughout the years. It's probably, I don't know, like 8 years already, which we since we started to work with iRODS, and we actually had 2 large projects successfully finished this year, which used iRODS to move data around, and we found very interesting things. We are looking forward for the, let's say, one port as a point of access to our solution, because we found that discussing network protocols with network administration on a large corporate, because we had a collaboration with a huge automotive corporate here in Europe, and they were filtering outgoing transfers, and we had to move like several hundreds of terabytes of data from them to our system. And it was a bit of a hassle to really like explain them, okay, we need all those high ports open, yeah. But I mean, the protocol works very nicely, and we liked it very much. In the research environment which we are in, this is very nice, and we actually use it to synchronize the microscope data between Brno and between Ostrava, yeah. Then HTTP API, this is great because it has an OpenID support, and we found one KWAP with S3 storage resource, but I hope that we will solve it quickly. Yeah, and we are considering actually to have the HTTP2 frontend. Currently, we have it written in Python, but we will probably explore Go or Rust or something which is like natively compiled to improve the performance, so on. Yeah. Okay, moving forward with some use cases and some nice screenshots. So this is actually a screenshot from the EFP interface, and this is how you can use the transfer API to manage files directly on the cluster, and we actually would like to have something similar also to for the iRODS. Yeah, this is like it uses the SSH certificates on the back and the JWT tokens exchange and so on. It's a very clever mechanism. Then another very important use case is the openwebsearch.eu, which actually scrapes the web every day and creates an open web index. You can access it there on the openwebindex.eu. And those boxes actually represent individual collections in iRODS zones, which may reside on different resource providers around connected to the platform. Currently, we are moving the open web search activities to Lumi iFactory, which means that there will be also Lumi G, Lumi C, and Lumi O infrastructures connected. Currently, it uses IT4I, Carolina, LRZ, and the CSC national clusters. but this is the ongoing part because Open Web Search EU project ended this year, and it's being moved to the LumiAI factory, or part of the activities there. So this is one of the very nice examples. And this dashboard actually uses LEXIS in the back. Yeah. Then again, this is how you can view the public web indexes in the portal, how it looks, how you can download it. Yeah. Another interesting application which is built on top of the LEXIS is an AI training app which focuses on AI models, lifecycle management, and also provides inference in the batch scheduled environments. And it also offers visual workflows which are focused on AI models, yeah, and so on. This is the inference service which we have developed in the Exaformine project, and you can actually use it to spin up an instance of a LLM in a batch scheduled environment, and it automatically keeps a job scheduled for you with your model. You can keep it running. It exposes the nice interface. Yeah, we know from all the other LLM interfaces. Yeah. Then some discussion about dataset importing capabilities. What we would like to do in the next step. Yeah, this is actually generated slide from textual representation, but we are considering to have a very well-defined standardized API to be able to pull the data from different repositories like DSpace, Invenio, probably completely custom APIs from some domain-specific data. We would like to have them pulled compared to the push model, which is more complicated. Yeah, and yeah, that's it. Thank you very much. Looking for questions.
All right, do we have any questions? Yeah, up here.
Hi, just a quick question. What does the typical job look like in terms of like the job script and also like the data that is usually sent to the platform?
Yeah, you mean in terms of size or?
Yeah, if you can characterize it like saying like this is what we typically see in the system, and maybe like some edge cases that you have experienced.
Yeah, I mean, we found most of the edge cases with AI because people really try to upload like several hundreds of thousands of small files, yeah, which are not bundled in any way, and it becomes very inefficient. So we have to help them. We implemented some like clever packing solutions in a client we have, yeah. But typically, for example, for the Open Web Search, the job the workflow has two jobs. One job is a Apache Spark job, and the next one is some custom processing in Python, which runs on GPUs. And typically, it pulls like, I don't know, several hundreds of gigabytes of data from local iRODS to the HPC cluster. This is the work files. Then it processes them, and then the indices have like several tens of gigabytes. So this is the output data. So this is one of the, let's say, big use cases we have. And then we have probably also some bigger ones like robotics, which work with like dozens of terabytes. Yeah? But these data are stored locally, and then they produce, I think it's videos and fine-tuned models, which are like in terms of gigabytes. Yeah, it's the output data sets. So ballpark numbers.
Yeah, and just follow-up question there, like, what is your experience with the redo or with the errors? Like, do you experience many of those that you need manual intervention as administrators to help the users, like to resend the job, to redo a job?
Yeah. We found that especially with the Exaformine project, that there were a couple of users which were sitting on really unstable connections, and we had to really implement the restored mechanisms in our clients. Yeah, so we keep track of. I think now it's file-based, so we keep track of what the last file was uploaded successfully, and then if the connection drops, the client has to restore the upload, and we will like follow with the next uncompleted file, and we remove the incomplete file there. We also had to implement the checksumming there. And what we would like to do in the next version is to move to the offsets, to the chunks, actually, not to the files, but to the chunks. Yeah.
Thanks.
Yeah.
All right. Do we have another question? Yeah, one in the back.
Hi, thank you for the nice presentation. So if I understood correctly, you said that you have removed the central proxy and the data directly goes between the users and the HPC
Yeah.
sites. So my question is, how do you then handle the logins and the firewalls of those HPC sites?
Yeah. This is what we use the OpenID for, yeah, because the transfer API, which is here on this slide, actually, this one, this is deployed on a target resource provider, but disconnected to the AI or OpenID provider, which is operated here in the left side of the slide, yeah. And we leverage that. So if you want to upload anything or download anything, you have to have a valid token issued by the AI. And the AI is connected. We are not let's say, we do not store the user accounts. We are connected to the different identity federations like MyAccess ID or U.B2Access and so on, and we leverage that. And also, same thing is used also in the EFP, the MyAccess ID. Yeah. So yeah.
All right.
Yeah. You good?